this section should explain the basic elements of the different stability matters and enable the user to understand the principle and effect of free liquid surface, its importance and practical precautions to avoid free surface as much as possible. Understand GZ and its importance. Know how to read stability curves. Know how G moves when mass is moved on board. Calculate GZ at small and large angles of heel. Have knowledge of the general stability requirements. If the ship heels, the centre of buoyancy B moves to B1 because the shape of the underwater hull is changing. The force working at B1 is still vertical and straight through the meta-centre M. On the line drawn between B1 and M, we now get a new point called Z. Z is placed on a straight angle from the line B1M through G. The distance between G and Z is a measurement of the forces trying to keep the ship from heeling. When adding a mass, which is not in the centre line of the ship will heel due to the heeling moment created by the added mass. The heeling moment is dependent on the weight of the mass and its distance from the ship's centre line. G moves towards the added mass. When moving a mass out of the centre line of the ship will heel due to the heeling moment created by the moved mass. The heeling moment is dependent on the mass and moved distance. The righting lever, GZ, is the horizontal distance between vertical forces acting through B1 and G. The stability depends upon the length of GZ and the buoyancy force. How to calculate GZ at small angles of heel. This is a typical GZ curve for a specific ship in one certain condition. To find the GZ value at one angle of heel, we use the following procedure. Start at the given angle of heel. Go straight up until we meet the GZ curve. We can read the GZ value by going horizontally out to the axis where the GZ values are written in metres. If we increase the distance between M and G, we will see that this has a great effect on improving the GZ values. The result is better stability. If the ship has a large GM value, the ship will roll rapidly. The movements can be very rough. Cargo and equipment may become unlashed. In extreme conditions, much damage could be done to the ship and crew. A GM that isn't very high or too small causes less strain on the cargo and equipment lashings and the ship in general. The rolling is slower and the movement more gentle. A small GM will result in little strain on the cargo and equipment lashings and bulkheads. The rolling is very slow and the movement is very nice and even. A negative GM may result in a constant list if exposed by an external force. This is because G was higher than M, but after heeling the GM might be positive again, due to the changed volume of the underwater hull. A negative GM may also result in capsizing. G is higher than M, and GM will not be positive before after the capsizing. At large angles of heel, the metacentre will move out of its original position, and we will have to use a more complex formula to calculate the righting lever GZ. This is simplified by the following formula. When moving a mass already on board, G moves parallel to the movement of the mass. When calculating heavy lift, the principles are the same as when adding a mass. The arm used to calculate the heeling moment is now the same as the transverse distance from the centre line to the end of the lifting gear. When the surface of a liquid is free to move, the effect is that G raises towards M. Gm decreases. The liquid will, of course, always move to the lowest side. The effect is mainly dependent on the breadth of the space where liquid is present. This is because the free surface effect is proportional to the breadth. With one longitudinal bulkhead, the effect of the free surface is reduced to 1/4. With two bulkheads, the effect is reduced to 1/9. The more bulkheads, the less effect. Practical precautions in order to reduce the effect of free surface: minimum number of daily service tanks in use, where possible, tanks either full or empty, bilges pumped out, freeing ports, side cuttles, scuppers, etc., clear and unobstructed. The healing moment caused by free surface is very dependent on the shape of the tanks. In square tanks, the effect is largest at approximately 50% full. These are the general stability requirements that are related to the topics dealt with in this module.